Let's take a custom object as an example. Simply put, Salesforce is a relational database. Custom object is a table in this database. Columns in this table are the object fields. Records in this table are the real data that correspond to your company business, such as address, name, location, amount, you name it. We ignore the records for now. Let's imagine that the table is empty. So the table itself is not a data, it's a metadata. When we create new custom object, we create a table in a database. Metadata is information about the table, about its structure. Metadata describes assets such as objects, tabs, classes, basically everything except your real data. Metadata does it using metadata types. Metadata is a base class. Metadata type is a class that extends metadata. The fields and values of metadata type are all metadata. It means we can deploy them from sandbox to production. All of us know that if we try to deploy business data from sandbox to production, it will be lost. That is why metadata types are so useful. We can modify org structure and we will never lose it. Metadata also defines how your org functions. For example, process metadata describes what happens when the user clicks the Save button. Presentation metadata relates to the layout of your org, and authorization metadata determines user access. It also describes your org general configuration. So we have metadata and metadata types. The tricky part, this custom object that we mentioned above as a table, is just one of metadata components, which is an instance of metadata type. And component could be simple, compound, or complex. Simple consists of single file. This type of metadata can be retrieved or deployed on its own without requiring other metadata components. Compound consists of two files. Let me show you. That call one another. For example, an Apex class or trigger includes two files, the class file and meta.xml file. Complex consists of files that may contain multiple named components. For example, a custom object may contain multiple custom fields, and each component, no matter simple, compound, or complex, belongs to a certain metadata type. Again, because it is an instance of a metadata type class, right? So we have metadata, metadata type, and metadata components now. Metadata type names are case sensitive. Specifying a type name with invalid case results in deployment error. Okay. Now about Metadata API. Metadata API works with metadata types and components. The main purpose of Metadata API is to move metadata between Salesforce orgs during the development process. You can move metadata with one or two ways. The first method is Metadata API deploy and retrieve call. Although you can write your own client application for using Metadata API SOAP calls, Salesforce provides the Ant migration tool to retrieve and deploy metadata. These calls are best fit for the final stages of development, such as deploy and tested customization to the production org. The second and easiest way to access the functionality of Metadata API is to use the Salesforce extension for Visual Studio Code and Salesforce CLI. I will show you how to do it later in this video. Let's take a look at use cases for Metadata API. A. Move metadata from production to your local file system. B. Move metadata changes to and from a Scratch org. C. Move metadata to a sandbox at integration points. It means after deploying on your own in a Scratch org or your local file system, combine work from your team at integration points in a sandbox. And D. Deploy metadata to production. Also, Apex Metadata API can execute deployment in only three scenarios. A. From certified managed packages that are provided by known registered ISV. B. From uncertified managed packages, but only if the subscriber org enables a specific Apex setting. C. From unmanaged packages, which means that the code is owned by the org that executes it. Some things that you can customize in Salesforce org aren't available in Metadata API. The following components can be retrieved or deployed with Metadata API, and changes to them must be made manually in each of your organization. Salesforce also doesn't allow creating Apex classes, Visualforce pages, or Lightning components via Apex. To work with metadata in your org, you can use ChangeSet or the Salesforce Command Line Interface, CLI. There are two easiest ways to move metadata between the orgs. I will show them right now. First, by using packages. Second, by using package.xml file. In both cases, we can use Salesforce extension for Visual Studio Code. Let's start with packages. Create project from command palette in VS Code. Then go to the package manager in your org and create new package. Then add some app to this package. Retrieve metadata from the org using sfdx force source retrieve -n and name of the package. -n means a comma-separated list of packages to retrieve. Check out in your local project. That's it. Now let's try package.xml. If you want to retrieve metadata from your org and then send it to ScratchOrg, you have to enable DevHub. Authorize your DevHub from VS Code using command sfdx auth web login -d-a devhub. -d means set default devhub username. -a means set the alias for the authenticated org. Again, please authorize devhub org, otherwise you won't be able to create default ScratchOrg from VS Code. I will use Trailhead module with name package.xml metadata management to keep it short. Go ahead and install the unmanaged package. This package contains one custom object with the name sticker. Create package.xml file in root directory of your project. Next, identify the metadata to be pulled by copying and pasting the following XML into package.xml file. Custom object, sticker _ C, custom tab, the same thing. Pull metadata package from playground. sfdx force source retrieve -u devhub -x package.xml. -x package.xml is to retrieve all metadata components listed in manifest XML file and add the metadata file to the force up folder. -u is a username or alias for the target org. Now you can create the scratch org that you will use to make changes to the metadata files and build more components for the sticker app, but we won't do that. The last topic is the custom metadata types. To understand custom metadata types, we must call in mind custom settings. Custom settings are similar to custom objects. Application developers can create custom sets of data and associate custom data for an org, profile, or specific user. All custom settings data is exposed to application cache. It's kind of local storage in the browser. Custom metadata types are similar to custom settings, but the fields of custom metadata types and the values of the fields consist only of metadata. The records of custom metadata types are also metadata. When you deploy apps with custom metadata types, all of the records and fields are included in the package installation, so no additional steps are needed. Unlike custom metadata types, when you deploy apps with custom objects and custom settings, the metadata for those objects, the header, get deployed, but the records are not. Custom metadata types support most standard field types, including metadata relationships, checkbox, date and date time, email and phone, number, percent, pick list, text and text area, URL, developer support. Developers can use SOQL to read custom metadata types. To create and update metadata records, they can use Metadata API. Apex code can create, read, and update custom metadata records, but not delete. Custom metadata types can be used directly from Apex, Flow, Formula Fields, Process Builder, Validation Rules. In many cases, custom metadata types have an advantage over custom settings and custom objects. They can make your application lifecycle management and compliance easier, faster, and more robust. The Metadata Namespace provides classes and methods for working with custom metadata and Salesforce using Apex. That's it.